So number 3 says the table shows the population density for the state of Texas in various years. Find the average annual rate of change in the population density from 2000 to 2009. So I only want to look from 2000 to 2009. My X would be the year. My Y would be the population density. So I'm going to rewrite this table. X and Y, 2000, 2009, 79.6, and 96.7. That's all I want to focus on, from 2000 to 2009. So what would my change in X be from 2000 to 2009? 9 years. Now for my population density, how would I get from 79.6 to 96.7?
17.1.
17.1. So if I was going to find my M, or my rate of change, I'd put the change in Y over the change in X. And that gives me 1.9. 1.9 what?
What is the question asking?
Well, my units for Y are people per square.
The annual rate of change in the number of students in the band.
Yeah, it's the annual rate of change in that. That's number 4. We're looking at number 3.
Oh.
The rate of change for population density. So it's changing annually at a rate of 1.9 people per square mile each year. People per square mile each year. And that's an average rate, right? Some years a little bit more, some years it's a little bit less, but throughout that 9-year span, each year has an average rate of change of 1.9 people per square mile. Alex?
Can we still put 17.1 over 9 as our answer?
Sure.
Okay.
On the test, you'd have a calculator. You could punch it in and figure it out.
Okay.
But, yeah, you can leave it like that if you want. That was number 3. On to number 9. Any questions about number 3? Anybody get that right? 1.9? Liana did. Raya did. Yusuf did. Ian did. Arisha did. Jaden did. Perfect. Number 9, if we're flipping over, we got a little table here. Determine whether the function is linear or not. Okay. I'm going to redraw my table. Bear with me. Bear with me. What does it mean for a function to be linear again?
It has to be a straight line.
It has to be a straight line. Good. If we're looking at a graph, that's easy to tell. But if something's linear on a table, what should we see?
Constant adding and subtracting of one single number.
Exactly. A constant change on the y and a constant change on the x. So what we're looking for here in determining if it's linear or not is where do we slip up? Where is there a number that's not the same each time? So for my y, I see I'm subtracting 0.3, subtracting 0.3, subtracting 0.2. That right there tells me immediately this is non-linear. It's going to be some line like this, and then it's going to change something like that. Not a straight line, not linear. And then I got another plus, or sorry.
Minus.
And then it's then it is a plus 0.3. So either way, there's two discrepancies there. But you can see if you had just used the first part of the table and gone, oh, negative 0.3, negative 0.3, I'm sure the rest are fine too. You would have got screwed over on that one. You got to make sure you're doing it all the time if they're asking if it's linear or not. Okay? Everybody good on number 9? Any questions I can answer about that? Okay, I'm going to assume we're good then, unless we're speaking up. 15, 5, negative 4, 9, negative 4. 5, negative 4, and 9, negative 4. All right? If I plug these into my slope formula, I got x1, y1, x2, y2, negative 4 minus negative 4 over 9 minus 5. Well, this is kind of like the warm-up. My 4's go away on the top. I got a 4 on the bottom. And just like we saw with our calculator, what's 0 divided by 4?
0.
0.
So m equals 0.
So my m is 0. Let's give 17 a try. What does 17 say? 17 says negative 3, 5. Is that the right one?
17? Yeah, negative 3, 5, 3, 6.
No, that's not the one I wanted to do. Which one did I want to do?
Check your paper.
Oh, 21, sorry. Oh, that was next anyway. So 17 we got negative 3, 5, and 3, comma 6. So if I set this one up, it's going to be 6 minus 5 over 3 minus negative 3. What happens when I have 3 minus negative 3? Turns into a plus. And I get 1 over 6. There's my slope, 1 over 6. So I think I saw a couple of people as I was walking around get undefined here. And that's because we forgot about the double minus sign, at least I assume. If I'm subtracting a negative number, subtracting a negative, we got to include both those signs and make them a plus. That gives us 1 over 6. But in number 21, we don't have that as the case. We've got negative 8, 6 and negative 8, 4. y2 minus y1 is 4 minus 6. x2 minus x1 is negative 8 minus negative 8. And we kind of see like what happened in 15 and in the warm-up. My 8's on the bottom cancel to 0. And I've got a negative 2 on the top. All right. If I see this 0 on the bottom, I know that I can't compute it. My answer is undefined. Do you guys remember what shape of a line would have an undefined slope? What would the line look like? Vertical. Whoever said that, great job. Vertical line.
Oh, yeah.
Like, think about plotting these points. Negative 8, 6. Negative 8, 4. Can a function have 2 points directly above each other?
No.
No, we already know that.
It's not a function.
So it's still linear, but we wouldn't consider that a function. That's why my slope is undefined. So it's kind of this is a really weird case, as you should be able to see. What would a line look like if it had a slope of 0? It's going to be diagonal. It's going to be horizontal. If I plotted these points, 5, negative 4, and 9, negative 4, got a nice horizontal line there. Right? I could walk across that line with 0 effort. Right? But if I wanted to walk vertically up the walls, that would be impossible. Cannot do it. Okay, that's one way to think about it. If you're walking on a flat surface, that takes 0 effort. If you want to walk straight up the walls vertically, it's going to be impossible. Cannot do it. All right?
It's impossible unless you have a superpower or something.
That's true, but for a normal person like me and you, it would be impossible.
Aww.
Last but not least, 25, 4, 6, 4, 8. 4, 6, 4, 8. Just like number 21, basically. Let me move this. M is 8 minus 6 over 4 minus 4. 2 over 0 is undefined. Give me a thumbs up if you got 25 right. Anybody? Did we talk about undefined slope?
No.
Perfect.
Yes, maybe.
We will.